Dear student, good morning and have a good day. Today I have the second um, practical lab of human histology to cover the theory lecture about connective tissue. So let me explain why do you learn histology, and because we have two main reasons. It's to understand how the cells and tissue are together in normal organ system of a human body, and also to know and to have idea about how the function between structure and function together most effectively. So, as we know that connective tissue started from a precursor of three primary germ layers. So I will start from center to outer, and here I have a sketch of three embryonic germ layer. It's endoderm. It's like inner layer or the center layer, and in the future will be forms lining of digestive tract. And while the mesoderm is the second layer or the middle layer, and forms tissue as muscle, bone, blood vessels. Ectoderm is the outer layer, and it is from skin, a neuroectoderm. We talk a lot about factions of connective tissue. Here I put only the main faction by blue color, enclosing and separating, connecting tissue to one another, supporting and moving and storing, cushioning and insulating, transporting and protecting. Here, I will start by loose or areolar connective tissue. Well, actually, I use two type of picture. One cartoon diagram, and the other is under microscope. So let's focus about under microscope, or the cartoon diagram will give you exactly where is found. So under microscope, you will see the loose or areolar connective tissue have too much of elastic fiber and collagen fibers with a nucleus. And as I said, connective tissue not be on the surface, so it's the second layer of the um, uh, of tissue. It starts by epithelium, and then it's underlying. And I have dense regular connective tissue. You will see the um, the main character have fibroblast cell. And now I say fibroblast cell, it's like elongated cell with cytoplasm projection, and the nucleus is ovate, and it's 1 to 2. It's not single nucleus, and surrounded by collagen fibers. This is regular. While irregular, you will see too much from elastic connective tissue, and it is found in aorta of heart, and also you found the second layer after the skin layer. Here we have adipose tissue, and you will see adipocytes of cells is like big cells or large cells with eccentric nucleus, and and with the narrow brim of cytoplasm. It's like a flattened cells. The reason we have eccentric nucleus or push the nucleus to age because it's a storage of fat and storage of oil droplets. As well as exactly found in here I give cartoon diagram for breast, hyaline cartilage. This kind of cells you will see under microscope is like a group of from 2 to 4 cells. And the chondrocyte, um, the chondrocyte, it must be covered by extracellular matrix of the cells because chondrocyte you will not find like a free cells. You must cover by black union. And as well, you will see nucleus and the matrix. Where is exactly found the hiding cartilage? It's an area for strong support and some flexibility, like we see the rib cage and cartilage in trachea and bronchi. Fibrocartilage, as I said, all type of cartilage, you will see chondrocyte covered by lacunae, and we will see nucleus, and the matrix here from this name is collagen fibers. It's like pretty self-explanatory picture. And where is exactly found is like in knee, in jaw, and between vertebrae. Elastic cartilage, that means the matrix have too much from elastic fibers, and a chondrocyte covered by lacunae, and um, and also the um, nuclei. It's here where is exactly found in external areas and epiglots. Let's we go to bone. It's a hard connective tissue and it consists of living cells and mineralized matrix. We say that for bone, it is the storage for phosphate and calcium substance. Here I have cancellous bone and compact bone. Cancellous bone or spongy bone, and it's like you will see under microscope, and I'm sure you will see this picture under microscope in human biology, and also the same pointers here: osteoblast, nuclei, um, uh, and bone marrow, and osteonucleus and matrix. This for cancellous bone. Where for compact bone we have the central of canal, and we have lacunae, and the matrix. Or the matrix is organized into lamellae. Another type of connective tissue is a fluid, is the blood. And here we have the matrix between the cells is liquid, and the hematopoietic tissue is the forms of blood cell and a bone. And you will see here the cartoon diagram for red blood cells is biconcave cells, and while the white blood cell different shape of cells. And bone marrow, you will see under microscope uh, stage the stage of the cells start to convert um, from the cells to blood cells with the different nuclei and the fat cell. Here I have a blood smear with different type of leukocyte. Here we have neutrophils and we lymphocyte and monocytes. Back to extracellular matrix, and I give only under microscope picture to see this. What is exactly that extracellular matrix? It's a ground substance, looked as I would like red circle, and the fiber is clear. The cells is also clear, or the matrix is from the fiber and the cell. Here I have in general under microscope picture, you see plasma cell is big cells with also tumor cytoplasm, and the nucleus goes to the eccentric or to the edge of the cells, and adipose cells is big cells with different pointers, mast cells, and also macrophage. Okay, for this slide, my lecture for practical is finished, and I know very well you have the connective tissue in human biology for a practical. If you would like to have more information about each slide, you can use the same PowerPoint for human biology. And as my um, to give you guide at the end of the each lecture. So let me go thoroughly on what is important to need to focus as a guide. All right. For me, the germ layer. This is the sketch of the three-layer embryonic germ layers. It is important to know and try to draw it and give exactly focus about not cartoon diagram about the only the under microscope. All right. So for example, this for carton and the skin and loose connective tissue, muscle and fat. And this is just to give you idea. Focus about only under microscope. And when you draw any tissue, please you need to know where is exactly. Um, for example, I put here for adipocyte fat cells. I give you fracture where is exactly in here as example in the breast. So in general, I think it's clear. Focus about on, as I said, focus about only the under microscope and where is exactly in the human body. Okay, and thank you so much.